This is a mathematical literacy topic, and we call it tariffs. Okay? Now, tariffs, you might not have necessarily known what they called, but I know you've encountered this stuff before. So there are four types of tariffs that they cover in MathsLit. That's municipal tariffs. That's when the government charges you for transport and electricity, not transport, oh my gosh, for electricity and water and other household expendables. Okay, then we have telephone tariffs. That's when you take your contract versus buying it cash. You have your transport tariffs, for instance, the Gautrain, Uber, Bolt, and all of that. And then bank fees, because for every transaction you do, you are charged bank fees, which is sad. Okay. Now, this is an example of what a transport tariff would look like. Have you seen this anywhere ever before? I know some people would have recognized this very quickly. Look at those destinations: Hatfield, Pretoria, Centurion. Do you know which specific train this is? This is what it actually looks like. It's a train. This is your Gautrain. Okay, I'm not sure how old these prices are, but this is your Gautrain, and this is what it looks like. Okay. So this is an advertisement for them for you to buy a 7-day ticket. So I mean, if you're a person, for instance, who goes to work every day using the Gautrain, you would maybe want to buy a 7-day ticket. Do you see what I mean? Instead of, I mean, because you're always going to get on the same station and you're going to get off at the same station. So, I mean, 7-day ticket works out better. Okay. So, the way this works is this is where you're going from. All these that are vertical is where you're going to start. So, let's say, for instance, on this day, you're getting on the train in Midrand. Okay. And this is where at the bottom, that's where you're going to get off. Okay, if you look at them, it's exactly the same names that are on the other side, but that's where you're going to get off. So, for instance, if I say I'm going on at Midrand and I'm going to get off in Rosebank, that would be 270 rands. Do you see how it works, guys? So it's like a cross table thing where you have to go and match. And I mean, going back the other way is the same thing. Midrand to Rosebank. Yeah, it's still 270. So it's not like a trick to charge you different prices. They're just trying to make it easier for you to check from the station you're starting in to the station you're gonna end up. Now, first question is very important. Why are there blocks that are shaded gray? If you look at this thing carefully, why do you think some blocks are shaded in with gray? Anyone have an idea? They're not available stops, not necessarily. Look carefully where the gray is. Look at the first gray block. That's a dead giveaway of why it's gray. Yes, they're the same place, right? They're the same place, guys. You can't get on at Hatfield and then just remain in Hatfield. That doesn't make sense. Nah? They are the same stops. That's why they are shaded in gray. Now, if you try to be dodgy and go give your friend something in Pretoria, that will not work because when you get out of the station, you have to tap your card. Have you guys been on the Gautrain? So to get in, you tap your card, and to get off, you tap your card again. So they're gonna catch you out. Okay, so you can't do some dodgy stuff like that. You have to pay for those trips. So the gray spots are all the same places. So they're gray because it's the same stop. Okay. Now, the second question says, between which two stations will the ticket cost you 387 rands? Between which two stations? Oh, but that's because, Alice, remember, it's a 7-day ticket. So let's say you are going there every single day for 7 days. Is it that expensive? Think about it. Or do you mean in general the Gautrain is expensive? Is that what you mean? Oh, I see what you mean. Yeah, I think this is a very, 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 very old price list of those stops. I'm pretty sure it's old. Okay? I'm pretty sure it's old. Because, yeah, I remember going on the Gautrain. For like a good 3 years of my life, I used it very, 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 very often. Because I was in university in Pretoria, and my home was all the way by Park Station. So that was, yeah. Okay. So, between which two stations, guys, does it cost 387? Has anybody figured it out? I'll highlight for you. There is a 387 over there. Pretoria and Centurion. Where's Pretoria? And Centurion is over here. No, that's 216. That's this one. That's this one. You see? So it is, in fact, Pretoria and Marlborough. But there is another one, and you guys haven't seen it yet. So the first one is Pretoria and Marlborough. And the second one, Maureen says Rosebank and Centurion. Let's see. Rosebank and Centurion, and that would be correct. So also between Rosebank. My handwriting looks terrible. I don't understand what's going on with this thing. And Centurion. All right. How much would a single ticket from Marlborough to Midrand cost? Marlborough to Midrand. How much would a single ticket cost? Let's hear what you guys have to say. Is that a single ticket? See, this is a trick question a little bit. There we go. Remember, this is a 7-day ticket. So for a single ticket, it would cost you 216 divided by 7. And let me get my calculator out. Let's see. If I can find my calculator, that would be wonderful. 216 divided by 7. That is 30 rands and 86 cents. 30 rands, 86. Okay. And then what is the price excluding VAT of a 7-day ticket between Sandton and Rosebank? Okay, let's first just find the price. For this, I'm going to need some space, right? I'm going to write here 2.4. Let's first look at the normal price. Sandton and Rosebank, how much is that? Sandton is over here and Rosebank is all the way over there. So that's 189. But these prices are always, okay, not always, but if they're advertised like this, we know they are including VAT. Now, how are we going to find the price excluding VAT? Does anyone have an idea of how we do that? I want to see if you guys have sort of an idea of how we do that. Anyone? We want the price including minus 15% of what though? Remember, this price already has the 15% included in it, right? Do you agree? So how are we going to know what that 15% is? Interesting stuff. I'm glad Alice knows that the VAT percentage in South Africa is 15%. You'll be surprised how many of us didn't know that. Ha! More lean. More lean. Wow. Okay, so mine looks a little bit different, but you'll tell me after I do it whether that's what you were saying, né? You'll explain to me whether that's what you were saying. Of the original price. But Alice, do we have the original price? See, that's the trick with the stuff. We don't actually have the original price. Do you see that? So are you first going to look for the original price? And how are you going to look for that price? Can we divide it by 7? No. Remember, we want the percent, the VAT percentage. So you cannot actually divide it by 7. Does that make sense? Okay. So I want to show you the little table that I show my kids, what I used to. Yeah, it's not as easy as everyone expected. Trust me, and this is not even the worst tariffs. Wait until they see electricity tariffs. You need to think. Okay, so I'm gonna take this stuff into perspective using percentages. Are we listening carefully, guys? So I'm gonna say my price, excluding VAT, is the 100%. Okay, and that's exactly what I'm going to do, Marlene. But I first want to figure out this percentage stuff. And Alice said that the percentage for VAT is how much? Percentage for VAT is 15. Okay, so that is 15. That means my price, including VAT as a percentage, will be what? Ha. Marlene, have you done this before? I'm starting to have suspicions. Okay. With me. Oh, I'm so proud of myself. Okay. And then we go to the formula Marlene gave us. So you always take the amount that was given to you. You multiply by what you want over what you have. Now, we have an amount of 189 over here. Times, what do we want? What does the question ask of us? What is it that we want? Which percentage out of those three do we want? 100. Lovely. We want the 100 over what percentage do we have? We have the 115. And this will equals, let's see, 189. I get 164 rands 35 cents. And that's your price, excluding VAT. Okay. Geez, I'm actually so proud that Maureen remembered this. I'm beaming with pride. So it's always the amount they gave you times what you want over what you have. All right. And then our last question says a single ticket between Midrand and Rhodesfield costs 31 rands. How much would a person pay if she buys, or save, excuse me, if she buys a 7-day ticket rather than buying a single ticket from Monday to Wednesday? To, I don't know, to where? To where? Okay. This person is actually not going to save. Let me spoil it for you quickly. Okay, because let's first look at the 7-day ticket from Midrand to Rhodesfield. 7-day ticket, Midrand, Rhodesfield. Okay, I can't see. My eyes are failing me right now. But Midrand to Rhodesfield, which is the last one over here, that will be 279. Not Rosebank, Rhodesfield. That's the one by the airport, if you've used this before. Okay, the one close to Ora Tambo. Yeah, so that's 200. So the 7-day one, let me go ahead and say 2.4. The 7-day one costs 279. Okay. Now, this person works Monday to Friday and a single ticket costs 31 rands. Now, Monday to Friday is how many days in the week, guys? How many days in the week? That's 5 days in a week. Okay, so you have to say the 31 rands times the 5 days, excuse me, 5 days. And how much would that cost this person? How much would it cost this person? 31 times that is 155. And that is in fact cheaper than buying the 7-day one because she won't use it for 7 days. Doesn't make sense. Can we get a thumbs up, thumbs down, and a little bit of a sneak peek of MathsLive? We're all good. Are we ready for mathematics? Ding, 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 ding. Ding, 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 ding. I'm just being dramatic. All right. Now, I think you guys have heard of the topic called trigonometry before. Okay, some of you may have done a sneak peek of it this year. I'm not sure. But let's look at a sneak peek of trigonometry. Okay. Oh, yes, to what? To have done it. Alice, have you done this? Yes, we are doing sine, cos, and tan. Yeah, see, some teachers give you a little bit of a sneak peek. So, this stems off of your right-angled triangle. Of course it is. Okay. And we have 3 ratios that we're going to discuss that have to do with this triangle. Now, generally, right now, what we do is we use Pythagoras if we have missing sides. But later on, you'll notice that we'll be using sine, cos, and tan to figure out missing sides and missing angles. It gets a little bit messier in the end, but I'm just doing the basics. Okay, so today we're going to be speaking about the angle called theta. We've already seen theta. I just want to highlight to you where it is because this is very important when naming your sides. Okay, so theta, as it stands where it is, your opposite side for theta would be AB. Do you guys see that? Only because of where theta is located. And your adjacent, which means next to, your adjacent side would be AC. Your hypotenuse doesn't change. We all know that, right? In a right angle triangle, your hypotenuse remains the same. So that guy is not going to change. Hypotenuse remains hypotenuse. But what you do need to learn is the definitions for the ratios. Okay, so the first one is your sine ratio. All right, and that is defined as the opposite side divided the hypotenuse. All right, my second ratio is my cosine, but we say cos ratio, and that is defined usually by, I need more colors here, the adjacent side divided by the hypotenuse, and finally we have the tangent side. The tangent ratio. I keep saying ratio, the tangent ratio. And that is defined by the opposite. That is too dark. We can't see. Opposite. Oh my gosh. I'm actually going to scream and cry. Opposite over your adjacent. This is why it's important to correctly identify where the opposite and where the adjacent is. Okay. So we do have inverse signs, but I'm not going to confuse you guys that much today. But I want us to look at this triangle over here. There's a reason I put this here. We have our lovely theta that we all know. What is this guy called? This other angle. Does anyone know what this letter is? What is that? This time we have 2, right? What is that side called? That is alpha, okay? That would be your angle alpha. So we have theta over here and we have alpha over there. There we go. Marlene knew that. Okay. So if I asked you for the sine of theta, it's what side over what side? Look at the top to guide you. That will be what side over what side. Just give me letters. Either AC or AB or BC. If I spoke about the sine of theta, that will be what side over which side? Does anybody see it? Okay, let me do sine. Eh? Maybe you guys are just nervous. I know you guys can see it. But my sine of theta, which is the red angle, will be equal to opposite, which is AB, over the hypotenuse, which is AC. Are we good? And then if I asked for the cos of theta, that is adjacent. Which side is adjacent to theta? Yes, CB or BC over your hypotenuse doesn't change, okay? Your hypotenuse doesn't change. And finally, the tan or tangent of theta is equal to opposite again, which we know is AB, over adjacent, which we said is BC. Lovely. Now, on the same wavelength, I'm going to now ask you for the sine of alpha. That's how we write it, by the way. The sine of alpha. So what's the sine of alpha in this case? It is opposite of a hypotenuse. What side is opposite alpha? That is? Yes. BC over your hypotenuse. And the cos of alpha is equal to, which side is the adjacent to alpha? That would be AB over AC. And finally, your tangent or tan of alpha, what will that be? Opposite, which is BC over adjacent, which is AB. Great. Now, I want you guys to look at these ratios very carefully. Do you see any similarities over here? Do you see any similarities on what I've written now here? The sine, cos, and tan of theta and the sine, cos, and tan of alpha. Okay, yes. Alice, tell me what you see. Tell me what you see. What do we see that is similar over here? The numerator and the denominator are swapped. Okay, for tan. You're talking about tan now. Okay. There, and there. That's true. What about the other four, guys? Look at the other four carefully. What do we see? Okay, the denominators are the same, but that's because the hypotenuse doesn't change, right? The hypotenuse doesn't change, so the denominators will be the same. If it's the same triangle, the denominators will be the same. What else do you see? Do you see that the sine of one angle is equal to the cos of the other? It's okay, Arian, welcome. And the sine of alpha is the same as the cos of theta. Did we all see that? So the reason that happens is just because, do you guys agree that a side that is opposite alpha will be adjacent to theta. That's it. Okay, a side that is opposite the one angle in a triangle will be adjacent the other angle in the triangle. That's the only reason that happens. And that's also why tan is upside down. Do we see, guys? Now, the reason I went through all of this is because you're going to need to remember the special angles. Now, depending on how nice your teacher is, they might not give you that table. Okay, that's actually something you're expected to know. In grade 10, there might be a bit lenient, but grade 11 and 12, 100%, nobody's going to give you that table. Okay, guys. So, these are special angles. And our special angles, the 3 is the 30 degrees, a 45, and a 60. Okay, now in a triangle, we know they're going to be right angle triangle. That's the first thing I told you in the beginning, right? They're both right angle triangles. In a triangle where one of them is 30, the other one will definitely be 60. How do I know that? How do I know that? In a triangle that has a 30 degree, the other one will definitely be 60. That's only because they add up to 180. Do you guys agree? It has to be a 60, 30, 90 triangle. There's no other way, right? Yes. And then in another triangle, you'll have two 45s, which makes it an isosceles triangle. Now, there are many ways that I have seen that people cram these ratios, okay? Oh, I have seen a lot. There's a fan. I don't know if you guys have seen a fan. I should actually go look at it, look for it for you. And then I'm going to show you what I mean. Some people just memorize the actual triangles. Some people might just memorize the numbers. I don't know how you're going to do it, but you're going to need to do it. Okay, let me see if I can find the fan for you. It's a little bit complicated. We had to know how to fill it, but only the top part. Okay, only the top part. It's called a unit circle. I'll paste it for you guys a little bit later. But if we look here, here's how I used to remember it, right? I used to have a little bit of a dodgy way of doing it, right? I would draw a triangle. Okay. And I would know this is 90. And the only ratio I ever memorized is that the sine of 30 is a half. Are we with me? Because I knew that sine is opposite over hypotenuse. So let's say I put a 30 over here and I put a 60 over there. I already know my hypotenuse is 2. Okay? And then I look for the side opposite to my angle, 30 degrees, which is this one. So that's 1. Then it's 1, 2, and the last one is a 3. Do we see? 1, 2, 3. It's a square root 3, but it's a 3. And then the other one is easy to remember because both the sides are just 1, 1, and 2. Are we with me, guys? If you forget the last side, you can just do Pythagoras. It's literally a right angle triangle. Okay. And once again, what we spoke about, if you look at the sine of 30, that's the same as the cos of 60 because the opposite for one is adjacent for the other. Same with the cos of 30, that will be the same as the sine of 60. And the tans are upside down. Okay, it's just that this was square root 3 over 1, which just ends up being the square root of 3. Okay, so let's use our newly found table and answer these questions. Now, just imagine in a test, they're going to give you this and they are not going to tell you the ratios. So I'm going to give you guys a little bit of time to look at the ratios, maybe take a screenshot. And let's see if we can do this without looking at the table. I'm still looking for that fan for you, or the unit circle. They call it a unit circle as well. And I'm going to show you how interesting this is. If your teacher says you need to memorize the unit circle, then she's out for blood. Okay, are we ready to see what the unit circle looks like, guys? Ready, ready or not? Okay, that's the guy. Okay. Now, the angles that we're speaking about, do you guys agree that they're all in the first quadrant? Because that's where 0 to 90 is. Do you all see that? So we don't generally go to the other side. We stick to the first. That's why I said fan, because usually they don't show this other parts. It looks like a fan. Do you see that with all those lines? So we're in, yes, this is cast, okay? So this is the first quadrant that we are looking at. And in the first quadrant, if you look at the coordinates, they go along with this table. Do we see that, guys? And there was actually a way for us to remember the stuff. If I can just find my pen so I can show you. If you are required to memorize this unit circle, I'm going to show you a trick now that we used to do. I actually don't need my pen anymore. Okay, so let's say you will be numbering from that side. Okay, you're numbering from that side. Do you see that this is a 0, 1, 2, 3? And then going from the side as well, 0, 1, 2, 3. The 2 is always a 2 because the radius is always a 2. Do you see that? So we never wrote it using the radius, which is the denominator. We just looked at the numerators. Look at the numerators, guys. 0, 1, 2, 3. 0 this side, 1, 2, 3 going up. But if you mess it up and you swap them around, then your whole unit circle is incorrect. I hope you guys are looking forward to learning this stuff. Okay. So that's your unit circle. So let's see. Let's see if we can do this stuff. Okay. Sine of 30 plus the cos of 60. Anybody find the sine of 30 for us? Or anybody know it? Let's hear. The sine of 30. That's the one ratio I knew like the back of my hand. The sine of 30, that would be how much? Must I show us the table a little bit while we're getting used to this stuff? Yes, Marlene, it is a half. So the sine of 30 is 1 over 2. And what's the cos of 60? Sine of 30, cos of 60. That is a very big hint that I'm giving you there. Here we go. Sine of 30, cos of 60. They are, in fact, the same. Do you remember? They are the same number because the ones opposite is the same as the ones adjacent. All right. Now my pen won't work. Isn't that lovely? But I want you guys to, on your papers, work out what is sine 30 plus cos 60. Yes, it's a half plus a half, which is a 1. A half plus a half, which is 1. Okay, let's move on to B. What is the sine of 45 plus the cos of 45? The sine of 45, and be careful how you write it. The sine of 45 plus the cos of 45. 1 over root 2. Okay. So it's 1 over root 2 plus, no, sine of 45. Yes, 1 over root 2 plus 1 over root 2. What does that give you? What is your final answer? Now we're gonna just use basic fraction mathematics, ne? Jeez, guys, I need to get a new writing pad. It's still not writing. 1 over root 2 plus 1 over root 2. Okay, usually if we do this, we don't use calculators, right? But if you do use your calculators, you can literally just press SD, right? But if you didn't use your calculators, what is 1 over root 2 plus 1 over root 2? If you're adding fractions that have the same denominator, you only add the what? Adding fractions with the same denominator, you just add the what? The numerators, right? So my final answer will be, I am fighting for my life on this side. See if I can write with my trackpad. That's terrible. So A we said is 1 over 2 plus, this is an eventful last lesson, 1 over 2 equals 1. Wow, I hope you guys are entertained by what's going on right now. And the second one, which is B, will be 1 over, we were doing well for a moment, 1 over square root 2 plus 1 over square root 2, and this gives us 2 over root 2. Oh my goodness, I'm going through all of it, guys. Woo! Okay, let's go on to C. This time we're multiplying them, right? This time we're multiplying them. So it's 1 over square root 2 times a1 over square root 2. And what would the answer be for that one? When we're multiplying fractions, what do? We just multiply numerator with numerator and denominator with denominator. So what would the answer be in this case? 1 times 1 at the top is very easy, but what is square root 2 times square root 2? What is square root 2 times square root 2? Is anybody still here? You guys went quiet like 3 minutes ago. There we go. It is indeed just 2 because it's inverse operations, right? Do you agree that it's like timesing the same number with itself? Square root 2 times square root 2 is square root 2 squared. And those will cancel each other out. Okay, so my final answer for this one will be equals 1 over 2. That's the best 1 over 2 I've written so far. And then let's move on to E. Let's move on to D. D says tan 30. So there's your table. Tan of 30 minus the sine of 30. So what is the tan of 30 here? Tan of 30 look carefully. There we go. 1 over root 3 root 3. Oh my goodness. Minus the sine of 30, which we know is a half. Now, I have a question for you. If you didn't have a calculator, how are you going to go about this question? What do we do when we are adding or subtracting fractions with different denominators without a calculator? Let's see if you guys remember your basics now that you're moving on to the big guy stuff. You make the denominators the same. So your first fraction, you would have to multiply by what? Maybe I should write it down first, ne? Your LCD. What is my LCD in this case? My LCD, look at the two denominators. They really don't have anything in common. And if we find something like that, then what do? It can't be 6, it can't be 4. Remember, that is square root 3. It's not a 3, right? That is a square root 3. So you literally just multiply them by each other. So your LCD will be 2 times square root 3. Do you guys understand that? If you have two denominators that have absolutely nothing in common, you times them by each other to get your LCD. So I know that my LCD in this case is going to be 2 times square root 3. So then in my first fraction, what will I multiply this fraction by? So it will be 1 over 3 times. How am I going to get the square root 3 denominator to look like my LCD? I have to multiply by what? Square root 3. What do I have to multiply that denominator by, guys, to get to the LCD? It is square root 3. So must I say square root 3 times square root 3? What's missing from my denominator from the LCD, guys? Look carefully. Your LCD is 2 times square root 3. I have a square root 3, so I have to times it by 2. Nice, Marlene. I have to times it by 2, but whatever I do at the bottom, I have to do at the top. Okay, and then you move on to the next fraction. Minus 1 over 2. This time, what am I timesing my fraction by to get to my LCD? There we go. So I'm going to say times. My times is tiny, but you can see it. Times root 3, but what I do in the denominator, I have to do at the top. So then my next step, if you guys missed it, guys, I lost my writing thing, okay? That's why my handwriting is doing what it's doing right now. So this will be 1 times 2 at the top. So it's 2 over 2 square root 3 minus square root 3 over 2 root square root. But guys, it's getting worse. Kanjani. Kanjani. Okay, and then in your final step, you'll just say this equals. You can't do much about it if you don't have a calculator. So then it'll equal, that went south very fast. This will equal 2 minus root 3 over 2 root 3. Okay. All right. And then we have E, which is the tan of 30 times the sine of 60. I'm not going to write. I'm going to let you guys do it. Let's hear tan of 30 times sine of 60. How much is that? Anybody working it out? The tan of 30 minus, or times, excuse me, the sine of 60. Hi, but guys, you guys know I can't write. Have mercy. Okay, it's fine. So you're going to say 10 of 30, which is a third, times the sine of 60, which is that. And yes, I see how you might have gotten that. We're not using calculators, Alice. We haven't been using them. Okay, so it'll be 1 over 3 times root 3 over 2. See? You didn't need a calculator. Because why? These guys cancel each other out, and you are correct, Maureen. My final answer will be 1 over 2. And I'm tired of writing like this, guys. So I think I'm going to call it a lesson. Officially logging off from grade 9.